Hello and welcome back to the Google APIs for Rust and YouTube Uploader development stream. It's Byron speaking, and it's all about the JSON tools now. The goal for today is to finish the JSON tools in order to write a filter that filters on lexical level and is able to take out key value pairs if the value is null. And because null is so important, you know, we will parse every kind of value here just for completeness and because it's not a big deal, I think. Let's parse the null value next, because that's what we are actually interested in. Everything else shouldn't bother us, but we have to be, it shouldn't bother us because stuff we don't know we treat as white space, and that's the cool thing. Yeah. So, the null value. So the thing is, in order to handle the null value, we have to understand the null literal. Let's have a test for that. Yeah, this thing. I guess I could actually start nesting these, but yeah. And also, I might want to put it down here. There. Okay, that's the null value. Lexing, basically. So that's an n, doesn't really matter. And what we get is null. So what we want to do now is, if you're not in a string, and if you see the n, we want to, we can't peek, that's the problem. We must not peek, that's a non-peeking implementation right now, even though I would love to peek. But with the iterator interface that we are getting, the only thing is take out the next value and never put it back. We could, of course, simulate a peek by then caching the peaked values and kind of reading them first, but I think that would make the iterator slower and harder to understand. So what I probably want to do is say, okay, I want to, if we start with, the n is kind of our marker. So let's put this in here, but not here. That's kind of the single case values here. That's the n. This is something we have to treat somehow. Oh yeah, and by the way, let's finish up this guy. So somewhere here, we skip 3 is always this value that is at the 4th slot then. This is some null value. No, it's not called like that, huh? Capital. I thought so. Null value like this, and it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 5 to 9. So that's our null here, and that's what we want to parse. And if we get that, it's cool. So that is our test already for the simple null value case, and I think that's our marker here, and this kind of puts us in the null value parsing mode. So from now on, this is kind of something we might want to do first. So I would like to have some sort of ring buffer, or not even a ring buffer, a buffer that we set that is able to contain 4 characters. And maybe we only have it set a few times, out of many. So what we have is an optional 4-character buffer, huh? So that's the null buffer. Let mut nb. I will document this later, not much later though. It's an array of 4 characters. No, wait. As a char array of 4 characters, I think that's how arrays are, what the type of arrays are, right? So just statically typed. Let's see if that actually works. And we start with none, and I shall say, well, this is a null buffer. So does it work? And what do we do here? We just skip it. So now it's like white space. That's still kind of all right to do. Let's just build it for now. So it doesn't mean it actually worked. Why is build not doing jack shit for me here? Oh, because I don't have a main. So without test, you can't even... They might have changed that. That is interesting. I thought you could build a library as everything else. But this thing never does anything now. What's the deal? Fresh. Really? Now it is fresh. But previously it's not fresh, man. Maybe it is for him, but that's a bug. Anyway, so aborting due to previous errors. Cannot borrow a mutable local variable as mutable. Lexer 72. Yeah, because we have to skip stuff here. Fine. Okay. Cool. So we have invalid. We don't because we. Yeah, I actually don't know why, but it's 9 to 11 here. What's 911? I mean, not that I would care, but we might as well. 9 to 11 looks like it's out of scope here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, okay, actually that shouldn't be here. So what's that now, just for the fun of it? Okay, so we get a curly close. And yeah, it skipped it as white space. I would expect it. So we get right to the end of it. So that kind of works. Kinda works pretty well. So here you can say, okay, that's our marker. And we managed to get the first piece of our puzzle here. So we say not self. NB is sum. And we initialize this with a beautiful character buffer of our character. And then just something that means nothing. X, which is not null. It's about that. So we have to fill in these x's here. And we also, well, have to keep a marker on where we are. So wait. Maybe it's more like a slice that we want to do here, huh? Or do we also... Now, well, if I want to have a slice here, then I can also might as well keep an index into that thing. And if it's that, then I might as well encode this into the index. So this is not optional anymore. This is always there. What about this? And yeah, we can... No, actually, I like the idea of initializing it because previous null values would still be in there. Even though we can... Yeah, I'm not sure. Actually, I like this, kind of. Yeah, this I like. So let's have a letmut. Let's have a NBI and null buffer index, which is a usize. Well, it's something we will do elsewhere. US. That's a null buffer index. And this will just be relevant to us if we have something here. So we set it. And the null buffer index shall now be at 1 because we have just set the 0. And that's kind of, that is that. And this is only good for us if we don't have an NBI yet. So if NBI must be 0 or wait, let's say, no, NB must be none in order for this to be valid. Otherwise, it's an invalid thing. So that's the state. We must not be in any kind of... Oh yeah, and if you're in a string, we don't do it. If you're in a string... No. Yeah, I just got a Reddit message because Killer Cup realized that, let's have a look at this. Realized that I was the one who got the 2000. It might actually directly to me. Okay, so I'm kind of spoiling private data here, but yeah, it's fun. No, I didn't win anything. Not even flowers. Yeah, we'll keep this open so I don't forget about it or something. And move away. There we go. Good. So if you are in a string, how do I do it here? If you're not in a string, right? Otherwise, we just ignore it. If you're not in a string, we have a chance to do it. And now comes the error handling, because we just ignore ends, obviously, inside of a string. That's what we do now. And we want to have invalid things if we have something here already. So what if the NB is already something that is not none? So if it's none, we are cool. Then we do what we do, initialize it. And also we have to set the, oh, we don't know the value yet. We will do it at the end. We have to parse it to the end now, right? So we're still invalid. That's cool. That's all good. And at the L, we have to check again now. That's kind of, I don't know if that's the best way of parsing this, but if we can't peek, you know, we have to kind of keep track of our state in some way and listen to certain key characters. I think that's how I would do it, at least. That's kind of my naive approach as someone who never wrote a high-performance Lexer of any kind or studied or something. So don't do what I do at home, people. It's probably a bad thing, bad practice. Okay. If it's sum, it's definitely a state we don't want to be in, because then we have seen something like n, multiple n's at once, and we are still kind of thinking we parse null here, which is wrong. It's just downright wrong. And yeah, we don't want to do that. And the same kind of dance we will have to do for the L then, which is annoying, but this will finish up the null parsing, and yeah, we have to do it like that. So, and if we, yeah, here we already know it's invalid. So type is and will remain invalid. This will mean that the stuff is invalid. Oh yeah, we should set the cursor. The cursor has to be set here, because that's some sort of thing. That's for sure, that we could possibly understand. So let's set the cursor, and this will remain. Oh, let's do it like this. And that's multiple ends behind each other. Call it invalid. Yeah, do we have to reset ourselves? I think we should reset ourselves. So NB is none. Yeah, now again, this resetting our state here is something that I would like to do only once. So reset null buffer. So that should start out at 0 here. I guess I want to have a little closure that I recreate every time, just for the purpose of ownership. I think, is ownership necessary here? Because then I lose my capability of accessing this at all if I bind it to a closure, even if it's here. So either it's just the closure that does the handling. I could do that. I could say, well, init or reset. And if it's kind of true, then I init. Otherwise, I reset. But I do the init only once, so there's no need for a closure for that. Yeah. Let's not do it. Let's just reset manually for now. even though I have the feeling I will do this in multiple spots here. And that's annoying. Yeah, so there, borrow checking is a bit, I know why, but this makes it harder for me. And getting the scopes right isn't, at least in this case, I see no possibility just yet, but maybe there is one. Yeah, but now I don't even duplicate stuff, so what am I saying? All right. So, actually, wait. What we are doing is, if we are in null parse mode, yeah, let's call it out. Let's just say, listen, this here is impossible. Because in null parse mode, we will kind of catch the character and say we fill in the next 3 characters no matter what. Which means we could hit the end before we manage the filling, so we have to check this here, like if you're still in null parsing mode, same with in-string. So this null parsing mode is identified by the fact that we have something loaded here into our null buffer. And that's the thing. So, so this is supposed to be none when we hit this, and this is just not there anymore. Panic. Yeah, let's call it unreachable. I don't want to make anything up, it's just that. It's totally unreachable. So if we are in a string, we don't care about ends, otherwise we will care about it. Okay. And then we initialize it, set the cursor. And I could I could match on this, get a reference. Let's see how that looks like. Does it work so far? No. US is illegal? Is illegal? Oh, usize now. Oh yeah, I forgot. Totally forgot. That was old old Rust. It was US and isize, which kind of was bad. And now it's usize and isize, which is good. Because it's consistent, even though it's a lot to type. No, it's the longest like suffix ever, but who cares really, huh? Who says that these guys can only be 1 or 2 characters long? 140. Oh yeah, true. I just match on everything here. NBI is never read. You are right, but it will happen. So now I think this does compile. Yeah. This value is never read. I know, but I like to see this yellow there anyway. So let's match on it. So if you have something here that, can I use if let sum? Can I get immutable on this? Ref mat? Can I? Let's try that. I think I should be able to do that. So we have a local NB, which is the unpacked null buffer. Yeah, and we will just say if this reaches 4, we will do everything I have to do to parse some sort of token. It's either a valid one or an invalid one, but it is something. And we will break out of this and thus don't even have to do the reset code because we will break. So once we had hit null here in the iteration, we are in null mode, right? And we don't have multiple iterations then, so we don't really have to reset ourselves. And string false. Oh wait, we do have to reset ourselves because why? Because of the way we work. Right. Oh yeah, because we have to check it here. Yeah, no, actually we don't have to. Oh, we do have to reset ourselves because we check it, but we just have to set the buffer to none and we are good. Good. So let's do this. Let's assign it. Okay, cool, we have something. So we expect the NBI to be at the right spot, so we can just put it in. NB NBI shall be the character. NBI plus NBI plus equals 1. Actually, if NBI is 4 already, we bail out. Otherwise, we increment it and continue with our happy lives. Like that. So if NBI is 4, then eventually we will... Oh, now that we have it in our grip, we can't really set it anymore. We are currently using this guy. Yeah, well. Yeah, we could also work with NBI then and make this a permanent citizen of our... Yeah, let's do it like that. I think that's easier. Let's make it a permanent citizen. I don't even know how to make a mass assignment. I think that's possibly not possible. Possibly it's not possible, but you can try. Can I is it, what is it then? It will not let me, it will not allow me. You know what? I don't have to specify it then. If I have to initialize it, and I believe I have to, then, you know, there we go. That's the type NB. There we go. So that's not that anymore. But if NB is greater 1, because that's our marker now. If greater 0. Greater 0. Then we set it. NBI is the character that we want. If NBI is already 4, then fine. We finish it up. Otherwise, we do it like that. Let's have a look at the NBI handling code again. The cool thing is that now we don't have to do this anymore, which simplifies it a bunch. Then we say NBI NB NB0 NBI. Actually, we know that it's 0. We can also assert for it. NBI is 0. Actually, I take the cheap assertion because that is under the hood more code, you bet. So that is 0, man. If not, something is totally wrong. And that's the kind of equivalent to the match statement that we had there. That's the assert. That's basically the part that verifies that we are not in some weird state, which was the catch-all branch arm previously. So NB0 shall be C. So we don't overwrite anything else. It doesn't matter. It's all about count here. And then when we increment it, can set it to 1 explicitly. That's fine. Set the cursor because here we start doing what we do. Nice. Then this guy will kick in and we'll basically fetch all the characters before we do anything. Once we fetched 4, we're cool because then we will see when we will verify that this is actually null in our buffer. And we know that the first one must be an N, so we only have to check 3 more. If NB1 is U and NB2 is L and NB3 3 is, and he could statically verify that our access is correct, right? I mean, it shouldn't have an index check here because it's clear that we are in the bound of that statically sized array. No doubt about it. Is L, so that's our null. We know NB0 is N. So then we are cool, that's the good part. Otherwise, we have the error handling part. I could also do matching here, which probably would look better. But I don't know about the slice syntax in match cases anymore. We could do that. That is kind of the same thing, but I like the idea of having exhaustiveness checking, even though in a simple Boolean case, there's no need for this, but I like the idea to be forced to do that, to be forced to exhaustiveness. That's kind of what I would like to express by match code. I want to be forced to be exhaustive. And here I'm like, oh, today I feel like handling the error case, and tomorrow I might not be. Okay. So what's the good case? The good case is we totally break. We don't have to undo anything we did so far because we bail out. We have to reset NBI because it will be read later to check if we didn't finish a null parsing there. And MMM. Yeah, and we set the type, right? T is token type null value. Here we go. Okay, and that's it. So we did not have a match. This means we still set. This means in any case we set NBI to 0 because we have finished the match. This is what we want to say. But only in this case we have a valid token type. I think this is what this means, and we always break. And I think that's the logic actually. Okay, fine. Then I'm even happier with this kind of approach. Cool, but we definitely break. And let's not forget, let's do this right away. NBI. If NBI is greater than 0, then we are in an invalid token. And in a way, oh yeah, it's interesting. We don't have to do this anyway. To check for unclosed tokens. Because we set the cursor initially anyway. And if we don't close it, the token type remains invalid. It's not. Oh, wait. Now we have to check for, whenever we parse something is in, now we have to, if we encounter curly, oh no, wait, no. We picked this out beforehand, right? That's the point here. So only here we would have to exclude that. Yeah, so it's kind of a good way to do that. Here we mix strings. Yeah, that's kind of our marker stuff, but we handle strings differently, that's for sure. For actually no real reason. The bad thing is Okay, let's implement it like this, and then we change string parsing to be the same, because then we can get rid of this. We can optimize this, and we don't have to reset our state afterwards, which will be faster. And also the string parsing will then be faster. And we have a benchmark to actually prove this. Because what I'm saying is that if we are in string parsing mode, we basically put an if condition here that says, oh, string parsing. Then the only thing we are ever interested in is a closing one, Awesome. That's what we do. I think I want want the assertion here to be debug assert. I hope that exists. Is there another assertion? Let's make it like this. So I think you wanted debug assert equal is not existing. Sad. Yeah, okay, so you want to do it like this, I guess. Yeah, that's fine. Just to squeeze out a little more performance. Okay. If n be greater 0, something is not to his liking. Okay, so but I guess there's no more stuff to be done here. What's the problem here? Error mismatch types. If n be greater, what's the use size? Oh, NBI. NBI. There we go. Cool. You like it? And we also want to have, just to not forget it, null value unclosed. Okay. Panicked, out of bounds, index out of bounds. The length is 4, but the index is 4. 99. I didn't break here or something? Oh. Sorry, if NBI is 3. That was my, I missed my abort routine here. And true, I don't have to reset it because I don't read it anyway. That's good. Oh my god, it worked. I like. Nice. What's the time say? Maybe we can put the string optimization into this one so that I don't have that much upload overhead. Okay, so that's the same thing, but we have Nuxel. So we have a 5 to 9, which is invalid. And we want to update our copy paste error. That's just a null. Unclosed. Sorry, did I not? I copied this because I thought, damn it, fuck it. I don't start at 0 here. That's an unclosed null value. Happy. Invalid null characters. Trigger invalid. Cause it to be invalid. So the cool thing is that you can then, it will just be invalid token, an invalid token here, and right afterwards just keeps parsing tokens as usual. It doesn't care. It's just a lexer. Nothing special, but I kind of like the idea that it's so dumb. Well, I can't help it, but it works. Yeah, let's make a commit here. Bang bang. Feed lexer null value lexing, including tests for normal null values and invalid ones. There we go. Cool. And I feel like I can relatively quickly update the string handling here so that basically we don't get the character matching here for all the stringies, and that will probably help me to get some more speed here, because the special casing is totally gone then. Totally. So we basically built this back into the main loop. That's nice. We just have to look for starters basically. Oh, but when we hit the numericals, then, well, it's going to be just a complex branch arm, and I leave it to the compiler to optimize the shit out of that. Okay. Ignore next. IGN next. What's IGN next, huh? Ignore next. Okay, the ignore next stuff we keep. Okay, if we are... Okay, so this we only hit. So here we have debug assert. Now we only hit this if we are not in string. Otherwise we don't hit it. And all the escape handling comes up there. So all we have to do here is set in string true, because then we can take the quick parsing route, which is basically what we did with the null value. Oh yeah, let's stash this real quick. I didn't save it. That's very good. Let's bench it just to see how much faster or slower. Just to have one value here. We had 415 previously. Wow, look at that. Are we that much slower now? Honestly, we are that much slower now. Crazy. So we lost a lot of performance just for this, just for this additional token. Yeah, but I think we will win performance now. We will win. So that's a good thing, because I want to get back to 412 or something. That would be awesome. So in string is true. And we set the cursor to mark the beginning. And all this stuff I just take out and have a look at it later. And we fall through because the next we don't want to ignore, right? This is not needed anymore then. It's kind of handling itself. The backslash ignore next. Something we still have to handle. Actually, the backslash we only have to handle if we are in a string. And this is something we have like most of the time, so we handle this first. And we are only in one mode, so it's a elif thing. It's, I think, not a good case for a match here. If in str, else if, oops, and so on. Oh, and we continue here. Yeah, so all this warning stuff I will take care of. So if we handle this, we have to either continue or break. This is the deal here in these quick routes, in these quick code paths. And then from now on, all the additional parsing, which is I think is only Boolean, and yeah, Boolean is kind of like a null, which is a bit annoying because we will have lots of duplicated code there. But hey, come on, it's a high performance super parser. And we will kind of do it the same way. It's kind of just grunt work then, but that's the style, the overall style. The good thing is it seems to work real well, and there's nothing that can go wrong. Oh yeah, many people have said that. Okay, so remember, break or continue. If you are here, do not let it fall through. I think that's also why we lost performance. So basically, we are really longing for these control characters to get into the fast path. Okay, so if you are in a string, and we shouldn't ignore the next one. And the thing is, this is ignore next thing. This is only because we will only handle this case. Yeah, I mean, if there is a stray character that we don't understand, we just ignore it. It's white space for us. So stray escapes or some things, we will just ignore. And this is how we are going to do it. We could also say, well, it's an invalid token if it's here. Just generally. I could do that. For now, I just copy this. So if we are in a string, then here is all the ignore next handling, okay? So if C is a backslash. Then ignore next shall be, I mean, what was the handling again? I copied it, but I didn't use it. Yeah, it's really all, and ignore next is true. And we continue. And oh yeah, that's this one. Otherwise we do this special handling. I think I want a special handling. I wanted to be able to detect that this is invalid, because we have a test for this too right here. So we will not break the test. This is invalid. Boom. There you go. And this also probably isn't necessary. Anyway, we had it, we thought it was necessary. Let's keep it then. It's debug assert anyway, that goes away. Good, set cursor, break, and we are done. String fast path. This is the null fast path. Good, so here, boo boo boo. If ignore next, that's bailout fast. If IGN next, then IGN next. Oh, true. If C. Yeah, here we check it. So if C is a quote, then we would have to do some termination stuff. But if we are in ignore mode, then we ignore this, just keep moving along, but disable it. So we do it, right? And this might actually be false behavior, because if there is an escape for a backslash, yeah, so this ignore next. So backslash within a string can be, I mean, right now we ignore it, but if a backslash escapes another backslash, then you have a literal backslash in there, and then there would technically be no escaping. And I think this is what we want to also model here. So I guess, yeah. This ignore false and continue we have to do as well. But what happens then? Then we would hit the next pause. I mean, that could be within the string, then we would hit it. Yeah, I think that would be the right behavior to do. So let's do it. So we can also escape other backslashes. So if we are ignoring ourselves, then fine, we do so and we continue. We play the game of on, off, as long as necessary. And this ignore next down here that we set, we don't set anymore. And now this continue special warning logic, blah, can go away. Cool. And I guess this is now a match here. Look at that. That's a, well, at least for the ignore next handling, because then we have kind of different branches. But I think I want this ignore next handling in a match. Do I? Oh, actually, maybe if IGN, if we are in ignore next mode and C is one of the two, C is that guy, or C is, oh no, that is not good. C is a backslash character. Then we set it false and we continue. That removes, come on, I could also type this. And then we continue and ignore the rest and we are good. So all this special handling is now gone. And now we can, yeah, this is also gone, totally so. And the rest of the logic I can probably figure out. So now we have a match here. Which says, and the optimizer can maybe optimize something there, you know, who knows? So if we have a string, so this means we didn't have to ignore it. Oh, come on. And I also want to do // now, which kind of changed. What's the time? Well, it is what it is. I can't have it. I can't change it. I mean, so // escapes it, and we should have a test for that. / escapes / in string value, that stuff. So if it's that, then we have to handle it. This is always the closing portion here. If it's a /, this is always kind of setting us in ignore mode. You know, it's kind of, oh, ignore mode and then continue. And we have to remember always continue or break here. Okay. All this stuff goes away. Wow, cool. That's a simplification. So here we close our string, which means finally we can set T as token type string value and break. That is that. Break out, we're good. We've successfully parsed an entire string here. And this should still work just fine. Oh, and also in string is something we don't have to check anymore because we catch it. Which also means that all this moves up again. So this stuff here also means the T equals token type and break logic will return. And yeah, this in-string stuff goes away. That's cool. Boo boo boo. No in-string in this match case, please. So that's the only ones, and that's the tedious work. But let's do multi-line editing. So T equals that. Colon break that. Boom. We're done. Oh, and the set cursor. Oh, the set cursor stuff was still, this also shared. But I don't want to have this duplication there. So let's do multi-cursor and let's live with the fact that we are a bit redundant. But that's how it is sometimes. So we set it. We set the cursor and we're done. And this is the only thing I have to take care of. So there, I think, for the sake of performance and considering we did it in one stroke anyway, we're good. And now we take all this one level up and make sure we have 1, 2, 3, 4, 5, 6 cases here. Kinda, huh? What? What are you doing? And I think it's just weird. I think it's okay. Oh, and I forgot. Put these here. Cool. And now this is what it wants to be. It's just looking for markers that will then trigger the fast path of the parsing. So let's see if it compiles. Cargo build. Probably, oh, it actually wants to compile it now. Non-exhaustive patterns covered. Oh, 104, that's the fast path here, huh? True. Yeah, I totally thank you. I totally forgot that. So in the catch-all case, we just continue. Because that's some character in a string, and we don't do anything with it. There you go. Have fun. And now it doesn't want to build it anymore, asshole. Cargo, like, look at that. That even still works. Oh my god. Faster, faster, faster. You must be faster, man. You must be so much faster. 400? 295? Are you kidding me? You must be freaking kidding me. That must be faster. It's simplified. I like the code more. Why would it be faster? What's the deal? Is it this? What if I take this one out? Then my test will fail, but just for the sake of benchmarking here. Probably doesn't make a difference, but maybe it does. 300. So each case kind of takes away like 5 megabytes. Yeah, but I want this case. It's okay. But it's crazy that these few additional if conditions, and debug assert is debug assert, right? That goes away. That's verified. Not that they have changed the meaning of it. But otherwise, you know, you wouldn't have it. Debug assert equal, with underscore makes sense. Okay, so that will be omitted. So I think we want to have debug assert equal then. Yeah, we do equal all the time. That code is not, that additional code that we get is not relevant. Oh, actually, no. Good. Is there? Yeah, I don't see anything else that I can do. Maybe now that we understand more values, it just gets naturally slower. But even in the previous case, the previous kind of style, we were faster than the custom match here. That's really interesting. It's not a fast path. That's interesting. But now we also allow to handle this stuff. What if we don't? Does it get super fast now? You gotta be shitting me. That's not true. Now it's super fast, yeah? This cannot be. This is like a compiler hiccup. Must be a compiler hiccup. Come on. It's like, what? This means we don't do escaping anymore at all, huh? And maybe then it can optimize it away. Do we? Yeah, then we don't set it to true anymore. And then it can probably optimize this stuff away. Yeah, I guess so. So this entire ignore string thing takes a lot of heat, eh? I didn't expect that. Not at all. Well, but I mean, who cares, right? 300 is still kind of in the greens. I mean, kind of. And maybe with the next one, I mean, it probably gets slower and slower every time. But that's just, yeah, anyway. Well, it's just the string parsing performance that suffers now. Yeah, I like to have a match here. I don't want to change a thing. Cool. But that's it. I think we are kind of at the time limit already. Let's do the / escape real quick. Think about how we do it. That's an unclosed string value. Now, an unclosed string value through a / we have tested here. No, wait, we didn't test it there. Yeah. Yeah, I think I just wanna show that this will be a valid string now, right? This is what we are doing here. And otherwise it wouldn't be. That's the point. If you would escape this one, I think I will have another test for this. So that is now a string value, and it spans maybe from there to there, but it's a string value. That's the important point. Oh, 2 failures? String escaping? Since when? But this worked, right? Oh, I probably didn't save it. Good. So left is string value with 510, and we have 58. Fair enough. Cool. And if you don't do this, then this is an invalid value with 5 to the end. This is 510 and 511 maybe. Invalid. So left is indeed invalid, 5 to 10. Ah, it stops there. True, it drops. It doesn't keep going. Then what happens then? So yeah, it's invalid. No, wait, what happens? But what's the next then? I don't understand. So if that goes to 10, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, okay, that's the end of the string. Good, that's what I expected. True, no, wait. Oh, yeah, the end of the string. Yeah, true, it's one shorter now. Seemed like the same because 10, 11 is now the curly brace here. But in this case, we have one character less, so the 10 is already the end of the entire string. So that's totally expected. Thank you. And one more time, just to show me that it's not magically getting faster. No, it's not magically getting faster. And even if I rerun it, it's not magically getting faster. Let's finish it up. So that was the fast path that isn't really a fast path. But it's kind of refactor, lexer, string, value, fast path. Technically, it's not a fast path, but it makes the code more uniform and easier to understand. It will be the default template for all other parsing, for all other lexing ability, for all other lexing we do. For instance, when right, implementing booleans. Yeah, so that's kind of totally not necessary to do that, because if you just want a filter that only drops null values, then we could already do that. You know, we know where the white space will be, and the white space for us might right now be even Boolean values, which are white space for us because we don't know how to parse them yet. But generally, you know, actually, the thing is, I'm implementing more than I have to just to solve my problem, but it's kind of interesting and, you know, interesting experiment also how fast it is. So let's just keep going. However, that will be happening after a break. Thanks for watching, and